Back to my series on functions. This video is going to be why the vertical line test works. So we're going to be looking at why the vertical line test works and how it's supposed to check for functions. So if you ever want to check to make sure that a graph is a function, you want to use the vertical line test. Now how the vertical line test works is you're going to draw a vertical line on the graph. And I'm going to choose the color red for this. So both of these graphs are going to be sets of ordered pairs. And what I'm going to do is I'm going to draw vertical lines down this graph. And it's going to go through the points. So I'm going to draw a vertical line right here. It's going to go through this point. I'm going to draw a vertical line right here. That's actually the y-axis. I'm going to draw a vertical line on this point as well. So I've just drawn 3 vertical lines, and with every single vertical line that I draw, I only go through one point. Well, if I only go through one point when I draw those vertical lines, that means that it passes the vertical line test, and it's actually a function. But if you were to look over at this example over here, this is an example of a relation that is not a function. So why is this not a function? Well, the reason why this is not a function is because it fails the vertical line test, and I'll show you how. If I was to draw a vertical line right here, where the x-axis is equal to 2, then what happens when I draw this vertical line? Well, I'm going through 2 different points, and if I ever go through more than one point, then the graph is going to fail the vertical line test. So since I go through 2 points, this is not a function. So that's how the vertical line test works, but I haven't really talked about why the vertical line test works. So just to give you an example, I'm going to be drawing from this second graph right here. Now for this second graph, what points do I go through when I draw my vertical line? Well, I go through this point. This point is 2, 3, 2, 3, but I also go through this point up here. This point is 2, 5, 2, 5. So what that means is when I put in a 2, I get 2 different outputs. I get a 3 and I get a 5. By the way, for the same input, right, I'm getting 2 outputs. So what does that mean? Well, what that means is when I put in 2, I'm going to get 2 different outputs. So one of the ways that I can write that is by writing f of 2. So f of 2 just means I'm putting 2 inside the function, and I'm going to get out 3. So f of 2 is going to be equal to 3. But notice I can also get 5 for an output. So I could also say f of 2 is equal to 5. I'll put this on the left side. So now I have the statement 5 is equal to f of 2, which is also equal to 3. Well, if f of 2 is equal to 5 and 3 at the same time, that means that 5 is equal to 3 by the transitive property of equality. So I get the statement 5 equals 3. Is that a true statement? Do you think that's a true statement or not? 5 equals 3. Well, that is a false statement. So I'm going to draw a line through that equal sign. So 5 is not equal to 3. But that's not the impression that you get when you do this little statement right here. So it turns out that for a function to actually be a function, any input must only have one output. And that's why the vertical line test works. If it didn't work, you would get impossible statements, like 5 is equal to 3. And that just doesn't work. So I hope that helps out. That's why the vertical line test works. And thanks for watching.